Hello, ladies and gentlemen. It's 27th February 2015, and we're on webinar number 7 of the schedule for 2015. Today we have Stephen Dreyer with us from Mettler Toledo CI division, and Stephen's going to be talking to us today about how to implement a successful vision inspection system program to prevent labeling defects. I'm sure that'll be of high interest to a lot of our attendees today. The consequence of mixing labels or getting labels with the wrong print quality on or print defects, print text, is a high hazard to consumers, especially with allergens and things. And I'm sure Stephen will be talking a lot about that shortly. I can see we've got a nice crowd here today. We've got over 100 already, which is growing all the time, which is great. As I mention each week to the regulars, these webinars are free of charge. Stephen's here today presenting free of charge, and that's made possible largely through our sponsors also, who I would like to thank. Our wonderful sponsors, Trace Analytics, Safe Food 360, the Foundation for Food Safety Certification, and International Featured Standards. You'll find more details about our sponsors on the website. Please take a look and visit their website and look at the products and services they've got to offer. They're a fantastic bunch of sponsors, and we thank them for sponsoring us in this great program that we are able to bring to you each week. Remember, we're reliant on technology today. We're live streaming, myself and Stephen. Stephen's actually in Chicago. I'm in Manchester, England, and you're all over the world. So lots of different internet connections. So we'll do our best, and hopefully it'll go without a hitch. So it's nice to see you all here. Okay. Without further ado, I'll pass you over to Stephen. Afterwards, we'll have the usual Q&A, and I'll invite you to submit your questions then. But for now, I'll pass you over to Stephen for his presentation.
Great, thanks, Simon. Appreciate it. Hopefully everybody can see my presentation here, how to build an effective vision inspection program. Again, I'm Stephen Dreyer, product manager at Mettler Toledo CI Vision. I'm here in sunny but cold Aurora, Illinois, and we'll jump right into this this slideshow here. So, the challenge. So, specifically from a food safety perspective, and sorry, let me back up one second here. So, we're talking about how to build an effective vision inspection program. I also want to talk a little bit about why. So, as I was thinking about this, I was thinking probably the why is just as important as the how. So we'll talk about the why as well. So the challenge here, especially from a food safety perspective with regards to vision, as Simon had mentioned, food allergies, a major concern for consumers. So we see food allergies have been on the rise over the past 20 years or so, having just about doubled in the population. Somewhere on the order of 33 million Americans and Europeans together have a food allergy of some sort. That constitutes about 8% of those under the age of 18 and about 2% of adults. Those who have food allergies, about a third have multiple allergies, and 4 in 10 of those have severe reactions to the food that they're allergic to. So this is a growing problem because we are experiencing more and more food allergies in the population. Also, from a recall perspective, it's been an issue for a long time, but it's growing. It's been growing over the years. So in 2011, 2012, FDA recalled of all the products that they recalled, 44% were due to an undeclared food allergen in the food being recalled. This is, as I said, it's been on the rise, but it's been an issue for a while. Of those recalls due to food allergens, somewhere on the order of 50 to 60% can be linked directly to a label mix-up, or a wrong label, or a wrong packaging. It's even more commonplace than these numbers would suggest, label mix-up, but it is primarily a concern here with allergens because there is liability that come with a mix-up when an allergen is involved, where it wouldn't be necessarily when an allergen is not involved. But a mix-up on a food that does not have an allergen concern is still a potential damage to a brand. Recalls are also communicated immediately with the internet, obviously. That information gets out and it persists for a long time after the event. Those consumers who are concerned about allergens tend to be more informed than the average consumer because they have to be. Their lives or the lives of those they care for are on the line. So the result here is a strong and negative response to highly visible recalls. And allergens, recalls due to allergens are obviously high visibility. So the impact of a recall due to a food allergen. So of recalls in general. So first of all, recalls are commonplace. There's a study recently conducted by the Grocery Manufacturers Association, and of those, those who were responding were food manufacturers and food retailers. The question was posed to the respondents of the study of how commonplace recalls were within the organization, and greater than half of respondents had said that they experienced a recall within the organization within the past 5 years. If looking at more than one recall, about 1 in 5 or 20% said that at least 3 recalls had occurred within the organization within the past 5 years. So recalls are commonplace. Also costly. The same study asked the question of how much a recall would cost, or what the size of the impact from a dollar standpoint would be on an organization. And more than 50% said a recall would cost the organization $10 million or more, and nearly a quarter said that a recall would cost the organization $30 million or more. So this is recalls are commonplace and they're costly, and they're a problem that we need to address, obviously. So we mentioned that of the recalls due to undeclared allergens, something on the order of 50-60% were due to label mix-up. What is label mix-up? So label mix-up is placing the wrong label on a product. It's mismatching 2 different labels on a product, so as to confuse a consumer, or they look at the wrong label and purchase it when they intended not to buy the food due to an allergen. It's unreadable information in a machine-readable code, such as a barcode, or it's a human-readable information that misrepresents what's contained within the product. The label mix-up compromises a product integrity, brand reputation, company profits. Oh, I apologize. I meant to move on to the next slide here. This would make more sense. Also, in the case of an allergen or an active ingredient, misidentification can pose a serious risk to consumers. Some examples given here. So a missing label with a signature at the bottom here, a ketchup label on something other than a ketchup bottle, a barcode which has information that isn't coded correctly, or an allergen declaration which doesn't have an allergen which is contained within the product. So how did label mix-up occur? 3 main factors that contribute: operator error, manual inspection, and equipment malfunction. So any mistake by human interaction with the packaging process or with the manufacturing process or applying a label can be classified as operator error. An example of that might be loading the wrong set of labels into a labeler during the product changeover, or forgetting to remove labels from a previous run. That would be considered operator error. The advancements in automated technology and the demand for higher output levels have made manual inspection unreliable and impractical. Inspectors can't keep up with human inspectors, I should say, can't keep up with advances in production speeds. And the result is that manufacturers open themselves up to a risk of mislabeled products slipping through the cracks. Equipment malfunctions can also occur, and typically that would occur in the labeling process itself. But it can occur elsewhere as well, from the printer all the way to the plant. So your primary, your label converter could print the wrong information on a label, or variable part marking that occurs at the plant could also occur, such as encoding a date code, a lot code, or a best before date or something of that effect. This can produce dire consequences if an ingredient is omitted from the label but is present in the product. So some of the regulations surrounding specifically food allergies. In the U.S., the obviously, which we heard last week from Frank about the Food Safety Modernization Act, which is intended to shift the focus away from reactive measures to proactive measures. These rules are still being written to support FSMA, but they're expected to strengthen these allergen declaration rules. But the slide here is referring to the rules that are currently on the books, or the laws that are currently on the books. So correct labeling assures retailers that they are in compliance with all federal and state regulations and are protecting store reliability. January 1st, 2006, this Food Allergen Labeling Consumer Protection Act of 2004 became effective, and this law requires that manufacturers clearly identify if a prepared food has any ingredient that contains protein derived from any of the 8 major allergic foods and food groups. If it does contain within the product, it has to be declared on the label. So the 8 major ones are listed here: milk, eggs, fish, shellfish, tree nuts, peanuts, wheat, and soybeans. And this is for the U.S. In Europe, the regulation that pertains to food allergies is this EU 1169/2011, which became effective December 13th, 2014. And it requires highlighting of the allergens in the ingredient list. In Europe, there are 14 listed allergens that have to be on labels. Same as the US, plus a few more. And that's shown over here: sulfur dioxide, sulfite, lupin. So also the food safety schemes. So outside of regulation, we have the food safety schemes that are GFSI benchmarked, such as BRC. These are considering the risk related to label mix-up and starting to talk about them in their food safety standards. BRC issue 7 is an example of this. It identifies a specific provision for label and packaging control in its latest issue, issue 7, which came out in January of this year. And others are likely to follow within the next few years. So, machine vision. I'll briefly just touch on this, just in case. This is something that's new to you. So, machine vision inspection system combines cameras, lighting, and image processing software to create an installation that is able to see objects and validate the acceptability at high speeds and with great accuracy. At its core, a vision inspection system will acquire an image, analyze that image, and then produce a result, or take a result based on what is seen and relative to what is expected. And what can it do for you? So machine vision is sorry, let me back up for a second. So we have obviously a lot of technological advances that help us do things better, but the human eye, backed by the human brain, is still a very powerful inspection tool. The problem is that humans get tired, take breaks, go on vacation. So where machine vision really comes in is that it's ideally suited for highly repetitive tasks and being there and doing it again and again and again. This reduces and eliminates human error and helps ultimately protect the health of consumers who use the brands and protect the brand owners themselves. So how to build an effective vision program. This is kind of the high-level overview. First and foremost, you want to gain support of upper management. Without upper management support, the project likely will not go very far. Or if it does, it won't be as effective as it could be. 2, determine what you want to achieve. If you don't know where you're going, you're going to have a hard time getting there. 3, select your partner. Partnering up with an organization that really knows machine vision in order to avoid the pitfalls of an implementation is ideal. Then implementation or installation and validation of the system, getting it on the line, set up, running, making sure that it's doing what you expect it would do. Then training your organization, your operators, on how to use it, how to maintain it, and then an ongoing support plan. How is that machine going to be checked and rechecked to make sure that it's working as expected? What's going to happen when something fails, when something goes down? How is it going to be maintained? So on the topic of defining the scope, I won't go through this in great detail. Really, you're going to be following HACCP principles here. So what are the things you want to control? Where along the line can you control them? What control can you put in place to validate or to check to make sure that what you want to control is being controlled? And then how can the control be verified to be operating as expected, and how can it be maintained and supported in the long run? Also, as part of the scope, what kind of data do you want to get out of your control? What's pertinent to your manufacturing process that you would like to see from the control that you're putting in place? In what format would you like to see that data, and how would you like it to be communicated as well? So all part of the definition of the scope. And then finally, line considerations. Do you have enough space on your line for this inspection? Do you have a new line or is it existing line? Will the product that you're inspecting and potential defect be visible at the point of inspection, or would you need potentially special product handling to take place in order to present the product in a way that it can be inspected visually? So kind of the big picture of a vision inspection complete solution, so taking all things into account. This is a graphic to represent that. So the graphic here represents all the key components of an effective vision program. In a vision inspection solution, value is not the result of the sum of its components. It's greater than that if done correctly. So there's a significant amount of engineering, product testing, and design and know-how that goes into each system to ensure that it is reliable and repeatable. The inspection solutions inspect reliably and accurate every day in a real-life production environment. Also user-friendly, so ease of use. This is a machine, something that an operator can come up to, can interact with, can make changes to, and understand what's going on. Or over time, if an operator hasn't used the system in a week or 2 weeks, will they know how to pick it up again because of its being easy to interact with, or will they have to go through another learning curve all over again? Ease of adjustment as part of ease of use. If your line is typical to most food manufacturing lines in the world today, you're going to be doing changeovers on a regular basis. If you have a system that can easily be changed over, it's far more likely to be used correctly every time. And then we talk about a little bit here about service. Having the system installed correctly, calibrated correctly, maintained correctly, all fall into the category of service there. And then we'll talk about hardware, lights, cameras, triggering, all these things, the physical component of the system. And then process and software, what kind of inspections are taking place, and how is the system interacting with your processes on your production floor in order to ensure that, that good product is getting out the door and defective product is being removed, and then actions being taken based on those defective products to correct your production process. So ease of use and software. We'll talk a little bit greater detail about these topics. So inspection capabilities of the system. The core inspection capabilities: reading, measuring, comparing, and counting. Combining these capabilities together in different ways to produce an inspection result. Finding, for example, a wrongly encoded information on the label, a label that is skewed, or making sure that the right amount of product are in a container. All capabilities of a vision system from a software standpoint. Ease of use, I'd mentioned before, the user interface should be something that can be readily interacted with. You're going to want to get potentially production trends. Hey, how many have we passed? How many have we failed? Are the numbers creeping up? Or are they going down? What kind of insight can you get out of your vision system. Having something that's configurable is ideal. Permissions and logging from a user interface standpoint, again, having a system where there is some sort of password protection based on who the user is. So being able to lock out certain functions of the vision system based on who's logged in, and then logging, knowing who's interacted with the system, what they changed when, and how that may have impacted the inspection going forward. Talk about ownership a little bit. The vision system shouldn't be something that's scary to operators. It should be considered something that helps them do their job better, and ultimately the job is to get the good product out the door and prevent bad product from getting to consumers. Grouping inspections and inspection results, another element of a key element of a successful implementation. Being able to perform more than one inspection potentially on a product, and then having a different and also just different points along the line, potentially being able to inspect packages as they're produced and as they're filled and as they're labeled, and having all those inspections tie together and produce a bigger picture of what's going on in your production process. And then having a system that you can expand in the future. If at first, just to get your feet wet with vision, 1 or 2 inspections are required or desired, that's a good starting point, but then ultimately, as your needs grow, it might be necessary to add more inspection points. So the software should be able to accept additional inputs at a future date. From a procedural standpoint, vision systems should help reduce or eliminate operator error. They should allow the quick selection of correct inspections from the get-go. And if you do have a changeover step at some point in the line, you want to have potentially multiple inputs from different operators, sort of a double check to make sure that the input from the first operator is correct. And the ultimate point here is that if you're set up to inspect the run product from the very get-go, then you're going to be you're not going to be inspecting successfully inspecting, or you're going to be rejecting everything off the line because your inspection is set up incorrectly. We talked a little bit about changeover. We want to make sure that the changeover process with a vision system is quick, is easy, is repeatable, and ultimately does not become a hindrance when a changeover event has to take place. Also, another important factor is systems to prevent bypass of the system. If, for example, the production line is geared towards getting a certain number of products out before the end of their shift, there may be temptation there to bypass a vision system if it's catching lots of problems and preventing them from reaching their quotas. So having a vision system that has a keyed or a way to lock out a bypass of the system is ideal. And then also there are sometimes more insidious, I would say, attempts to bypass vision systems. For example, putting a picture of a good product in front of the camera to simulate that a good product has passed by the vision system. So having some way of catching those attempts to circumvent the system would be very important as well. I'd mentioned before making sure that the system is operating correctly. So having a challenge set, a set of good and bad products, and some kind of a procedure to walk through and test on a regular basis. Is the vision system operating as expected? What do you do with rejected products? Do you want to have an alert? Do you want to sort those rejected products? Are there 2 different reject bins, one for product to recycle or to rework, and another bin for product to throw it away? Vision systems should also drive improvements to the product quality and safety in your production process. Vision system could be a band-aid just to catch bad products, just to make sure that products that have defects don't find their way into customers' hands. But it can also be so much more than that. It can be a tool that you use to determine where there are problems in your production process, and then take steps after you've found, for example, from the trending information that comes out of the vision system. These are the areas that we need to work on in our production process. That's ideally what a vision system will be able to do for you. From a service standpoint, really, and I mentioned this before, picking a provider, somebody who knows what they're doing in machine vision. You want to have an end-to-end project management, a single point of contact who can answer all your questions about how a vision system should work, how that specific system will be set up for you. Also, acceptance testing, having a way to verify that the system is working as expected before it even leaves the facility where it was produced, even before it's on your line. Installation and qualification, or installation, which is qualification and validation, very important step as well, making sure that the system gets on the line, is set up correctly, and is working. I'd mentioned the checking challenge sets. Also want to talk about maintenance, so ongoing support of the system. How is the system doing? It's on the line, it's operating, I see a light flashing, is it still working as expected? If you do have a catastrophic event and the machine goes down for some reason, is there some sort of backup plan? Do you have the software stored somewhere that can be reloaded onto the computer or onto the vision system and start it up quickly so that you don't have downtime? If in the future you have additional SKUs or new labels that you get onto your products, is there a way to set up new SKUs rapidly? And I've mentioned here remote new SKU setups. So is this something that that can be done? Does it have to be done at the machine, at the vision system, or can it be done remotely by somebody in another office? And then training. Once the system is installed, having operators trained up on how to use the system by knowledgeable personnel, walking through what are the steps to make the system work, and then a back and forth with the partner on how to set up a document that describes the use of the system. When it's necessary, when a part goes down in the vision system, where are you going to go to identify or to get a spare part, to get a part to replace one that's gone down, or even will you have one of those potentially on hand so that instead of waiting a day or two to get a new part or a replacement part, or even longer, you'll have one on hand and ready to go. Custom and documentation if required. If you have a requirement to make a vision system part of your process and document it, is that something that can be provided, or is something you have to do on your own? And then global support and service. Some vision systems obviously are installed only in one facility, in one place in the country. In our experience, it's more common for vision systems to be installed in multiple facilities across the country or even globally. Is there some kind of support network in order to service those systems wherever they might be? And then we'll talk a little bit about hardware. So the hardware that makes up a vision system, usually some sort of camera, some light, some kind of dedicated processor, and vision algorithms to process the images that come in, and then a tracking module of some sort, something to identify where the product is from point of inspection to potentially point of rejection. Another thing to consider with tracking, monitoring inputs for blockage or disconnection. I mean, these are things that again, from having experience with implementing vision systems, these aren't things that get caught necessarily all the time at the very beginning. This is sort of like a garage door sensor that I'm talking about here. Are your inputs blocked? Are you even inspecting? Or has your trigger sensor, your sensor identifying where the products are on the line, has it been blocked? And is it operating correctly? Verification of rejected products. From that standpoint, if you've identified a product that's defective with the vision system and you want to reject it, is there some way then of looping back around and saying, yes, indeed, the product has been rejected, it's been kicked off the line? So some sort of verification that a product that is bad, determined defective, was actually physically defected. And then you also want, from a tracking standpoint, a system that will account for variation in line speed. Line speeds up, line slows down. That's accommodated within the vision system tracking. Rejection, many vision systems also involve a rejector of some sort, a way to remove products from the line. Ultimately, you would want to have potentially different options for rejection for different products. Lighter products, maybe an air blow-off. Heavier products might be a physical rejector. Fragile products may need some sort of a soft reject mechanism. So different types of rejection is essential for different vision systems and different products it's rejecting. Visual or audible alarms, also important. Some way to identify to operators on the plant floor what is the status of the machine, what is the status of the inspection, is everything working properly, or is there something that there's some service needed or some attention by the operator needed. And then in cases where you might have washdown in your facility, you may need a different environmental protection from a hardware standpoint for the vision system. A couple other things to consider here. Label safety and quality inspections. So what type of inspection is being performed? Is it a quality inspection? The location of a label? Is it a position, skew, or alignment? You have a flagged label potentially. Or are we doing identification inspections? Are we looking for some sort of a barcode, 2D code, alphanumeric code, or graphic? These are all things that need to be considered when implementing a vision system. What inspections need to be performed? And then finally here, the other factors to control and understand. What type of label is being inspected? Here we just have a list of a couple different common labels, pressure-sensitive labels, in-mold labels, shrink labels, and hot and cold glued labels. And then what kind of package type also influences the type of vision system deployed. Is it a round product? Is it some kind of a flat-sided product that's freestanding? Is it a flat package, or is it on a web? And then finally the print types here. Inkjet, hot print, laser, preprint, embossed, ultraviolet, or thermal. This will all impact what type of vision system is deployed and what tools within that vision system are chosen. So some additional issues to consider when implementing a vision inspection program. In a recent study we conducted, we revealed that somewhere on the order of 90% of all vision systems fail to meet and exceed user expectations. There are a number of reasons for this, but some of the heavy hitters are the ones listed here. Starting with a standard solution that can be tailored to a specific requirement on a specific line. So if each system is built from the ground up and kind of reinventing the wheel, the risk of the system not working as expected is much, much higher. A vision system implementation doesn't need to be a science experiment. There are solutions on the market that answer most of the inspection needs that are out there. Also, avoiding centralized expertise. So if a vision system is installed by one specific person, the risk there is that person may end up leaving the company at some point, and then all your vision knowledge goes with them, and therefore you've got a vision system that doesn't work because nobody knows how to use it. Ease of use, I'd mentioned this before, especially important for setup and product changeover. The vision system should have the ability to quickly be adjusted to inspect one product to another, obviously because of the prevalence of product changeover on the line. It should also be flexible. So marketing will change, and I'm sure all of you are aware, marketing will change the color, shape, and size of a label. The vision system has to be able to accommodate these changes without too much trouble. Margin of error, I mentioned this here because just good enough is not good enough when it comes to an effective vision system. If it doesn't accommodate changes, then over time it will become less and less useful, and it won't be inspecting as expected, won't produce the results expected. And then finally, expandability. So added inspections, inspection stations over time as need changes. The vision system should be able to handle those without, again, too much trouble. So a couple conclusions here. Ultimately, food safety is a cost-benefit analysis. Technology is often the solution to mitigate these risks within food safety. But the real question, I guess, is what is the threshold of acceptability? If a technology is too expensive, it won't be implemented. But if it's cost-effective, if it reduces risks, if it leads to more profitability and more satisfaction from consumers, it makes sense. The threshold of acceptability with regards to machine vision, some things to consider. Consumers have a very low tolerance for a defect when they can link that negative experience that they have with a product back to the manufacturer. An example I might use here is with pathogens. Very important, obviously, that we reduce pathogens, that we make sure that food is safe from a pathogen standpoint. But if a consumer eats something and they get a little upset stomach, they're not necessarily going to know who to point the problem back to. If they have a food allergy, though, immediately after they eat that food or they consume that product, there's going to be a reaction, and they'll know directly who was responsible for it. Regulators also now expecting prevention rather than just reaction to food safety events. So another factor to consider. The threshold of acceptability, I believe, is going down with regards to allergens in food products that are not labeled. So machine vision has a lot to offer, but its effectiveness definitely depends on how well it's been implemented. But ultimately, an effective implementation of a vision system, machine vision system, offers peace of mind to the brand owner and consumers that they serve. So that's a conclusion of my presentation here. I'll turn it back over to you, Simon.
While you were presenting, I set a poll just asking a simple question. Does your business currently utilize vision inspection systems, yes or no? And we'll have a look at the results of that shortly.
Great.
It would have been nice to ask another question, which would have been, do you currently get labeling problems, mislabeling, missing print, labeling the wrong product, out of alignment, blah, 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 that type of thing. But anyway, we've asked that question about do you currently utilize it? And there has been some people typing in, and specifically, I will go back and say it again, I've just been talking about it. Gary, who had a lot of experience accompanying with vision inspection systems, and I suppose you could say it was initially, it was a poor implementation that resulted in £25 of product being rejected every hour, and then it becomes a case of the boy who cried wolf. You don't trust the system,
right?
It's garbage in, garbage out. It's high tech, but if you set it up badly, so is that one of the key things? Do you think then, Stephen?
Yeah, absolutely. Yeah. So I'd mentioned that a vision system can be a band-aid to prevent bad product from leaving your facility. In the same way, it can be a false sense of security. If it's incorrectly set up and passing product that's bad, or it can become a hindrance if it's rejecting product that shouldn't be rejected from the line. Obviously, if the vision system detects product that should be rejected, it shouldn't be considered a nuisance. If it's really out of spec, if it's really a problem, then the next step should be that you go back to your manufacturing process and find where the defect is being introduced and work on ways to reduce that. But certainly, if a vision system is installed and it becomes a nuisance and rejects product that shouldn't be rejected, it can become it can leave a bad taste in customers' mouths or in users' mouths. And that's why I mentioned the study that we conducted at Mettler Toledo CI Vision that determined that the vast majority of vision system implementations end up in a nominally successful or totally unsuccessful vision program.
Yeah. Okay. I just wonder, in your experience, Stephen, how many you must, when you go to these a new customer, a new prospect, how many are following some sort of crisis? What sort of percentage would you say would be proactive and reactive?
That's another good point. Yeah. So, um, unfortunately, the impetus to deploy a vision system is typically the result of some sort of a bad experience without vision. So that might be a recall event. It might be just a lot of consumer complaints, as I mentioned. Sometimes a wrong label when there's not an allergen is not necessarily something that would cause a recall to occur. But if you have enough, if that occurs, if you get the wrong flavor of jelly bean, for example, it might be just a lot of customers who are upset, and then a lot of call-ins, which then would cause an assessment of the need for a vision system. So reactive customers typically are reactive to the needs for a vision system. But really, the benefit to implementing a vision system is being proactive, removing that recall altogether. And you might go a long time without a recall, but when a recall does hit, it's extremely expensive. Having a vision system in place ahead of time can prevent that, and that's your ROI immediately. To have prevented a $10 million recall with a vision system, it pays for itself very quickly.
Yeah, I suppose that often after that expensive recall, often the missing senior management commitment suddenly appears.
Absolutely, absolutely, yeah.
So that is that something that you tend to do when you're doing an implementation? You'll sit down and spend time looking at what are the key sort of quality points, and sort of which, I suppose, doing a risk assessment on them and saying which ones, like let's say for example, a label out of alignment is not very nice, but it's not going to cause anyone, an illness or anything like that.
Right.
Is that what the sort of thing you do? You sit down and do a hazard analysis sort of thing?
Right. So yeah, absolutely. So typically we as Metler Toledo CI Vision would sit down with the customer and say, what are your needs? What absolutely do you need to prevent from leaving your production facility? What would you like to see as well? And then what would be great to have if you can get it without any addition, without too much extra effort. So first, focusing on the highest risk items, and then working the way down the list to those things that are great to have. And typically during that process, there are additional kind of needs for inspection that pop up as obvious. Well, also with talking about what's possible, what's feasible. Sometimes customers aren't aware that the technology exists to do certain inspections. And that comes out during that first part of the process of analyzing, what are the needs, what are the requirements, and how can something be built to take those into account.
Yeah, and when we're talking about vision inspection, can that be also things like checking the label on a pot matches the label on a lid, for example, so that what sort of different range of vision inspection systems are there, just as a matter of interest?
Sure. So making sure that two labels match up is a very common inspection type. So a great example of that would be like an ice cream container. If you have a chocolate ice cream and you've accidentally put a vanilla lid on, that could be a real problem. So yes, inspecting the label of the product and the lid of the product to make sure that they match up, definitely one of the more common inspections out there. Just making sure that there's not mismatch, and that might also be on a label on top of a product and on bottom of a product, making sure that the declaration of what the product is, kind of the fancy graphics on the front, match what the ingredient list is on the back of the product. For example, tray packed meats, you might see a label on top and a label on bottom, and they need to match, obviously.
Yeah, yeah, sure. I've just, as a matter of interest, I've just closed the poll now, and the question was, does your business currently utilize vision inspection systems? And the answer is yes, 13%, no, 87%.
Wow.
Yeah, that's quite a large proportion of no's. And, you know, I was speaking to the audience while you was away for that short time, Stephen, and we have a range of attendees here. Will be from, you know, global manufacturers right down through small, medium enterprises down to your mom and pops, where you're hand applying labels and things like that, and not always high speed. So I suppose the relevance and the need for vision inspection does, I suppose, increase with the, you know, higher speed manufacturing, etc. Would you agree with that?
Yeah. So I tend to. So if the level of automation in a facility is relatively low, then it is true that you know, manual inspection is great up to a point, because as long as the product is moving along slowly enough, and the inspector has enough time, then you can physically inspect products up to a certain speed. There are some issues with reliability and distractedness of the person doing the inspection, but typically, I mean, at those speeds and the way that those lines are set up, when they're more manual, there are less opportunities for an automated inspection. As the inspection speeds go up and the automation in the facility goes up, then yes, the implementation of a machine vision system is going to usually be more useful in those sorts of environments. Although I would say that there are definitely times when a semi-automated inspection can also take place, where a vision system is set up, and then a manual operator would place then a product in front of the vision system and do an inspection and then move on. So there are. It doesn't have to be a fully automated system. There can be some steps in between.
Yeah, okay, that's interesting. Somebody, Theo, has just typed in, I just sent out a new product with the wrong barcode and the problem was discovered by the client. I think we need a barcode scanner to fix this issue. A vision system too could also be another alternative. Yeah. So a vision inspection could be just inspecting the barcode, I guess.
Potentially, although, and at least in my experience, a barcode might not necessarily give you all the information you want to. I mean, is the barcode unique to that graphic on the label, or is the barcode used on different labels with different graphics? Sometimes, I guess, what I'm trying to say is sometimes a barcode inspection is not enough to correctly identify that the right label has made it onto a product. Sometimes it requires more than that, some kind of a label tracking number, or potentially looking for a graphic that's unique on that label, even if, again, the barcode may not be unique to the label. It might require more inspection than just that. And then it also doesn't cover, just a barcode scanner doesn't cover the issues of label quality. You know, is there a fold somewhere in the label? Is the label skewed? So yes, a barcode scanner may work in some instances, but there's much more you could do with a full-on vision inspection.
Yeah, I mean, at the end of the day, it's mistake-proofing, isn't it? And in my experience, which is food packaging, so printing and food packaging, line clearance is a big issue, but it takes a lot of, it's a labor-intensive process, you know, and especially these days as well, we find that batch sizes are becoming smaller and smaller, so there are more changeovers, more clean downs, more line clearances, and you're relying on people who are tired, stressed, thinking about the holidays, the weekend, or whatever, and when you rely on people, then mistakes inevitably will happen. We're wrapping up now, Stephen, because we've approached the hour mark, and what I'll do is I'll capture these unanswered questions and comments, and I'll post them on the IFSQM forum.
Great, excellent.
hopefully you'll look into that and maybe
Absolutely.
add your comments to there. So thanks very much for this, Stephen. I've
Thank you.
enjoyed it. It's been a good discussion, good webinar. So thanks from all the attendees and the IFSQN. I hope to see you again sometime.
Absolutely, and thank you, Simon, very much, and I appreciate the opportunity to talk to all of you. Apologize for the technical problems that we've had here today, but yeah, thank you very much, and I look forward to seeing any comments and answering them as I have time and as you have time to put them up there.
Okay, Stephen. Thanks very much.
Take care.
Okay, ladies and gentlemen, that's it. We'll see you next Friday at the same time for the Food Safety Fridays. All there is to say is we say it every week is have a lovely weekend. Take care.